Oh, we're given a rate at which the water is pumped into the tank, W of t. And we are also given a chart representing R of t, which is the rate at which it's being removed from the tank. And we're also given an initial condition that at the beginning there are 50,000 liters of water in this tank. So first thing it wants us to do is find R prime of 2. And it says we have to estimate it. So to estimate the value of the derivative of a function that we don't actually have a function for, we just need to find the average rate of change surrounding 2. So that means we're going to use the average rate of change around 1 and 3, which ought to just be the slope between 1 and 3. So that should be 1190 minus 950 over 1 minus 3. And that comes out to be, what is that? That's 240 over negative 2, which would be negative 120. There's the work that leads to our answer. Indicate units of measure. So units of measure should be the units of R of t, liters per hour per time period. So liters per hour, or liters per hour squared. Any questions there on part A? They gave you 1 point for negative 120 and 1 point for liters per hour squared. A whole point for those units. Isn't that nice? All right. Everybody ready for part B? Everyone's good on part A? Cool. Part B, use a left Riemann sum with 4 subintervals indicated by the table to estimate the total amount of water removed. So total amount of water removed ought to be the integral of R, right, from 0 to 8. And so they're asking us to estimate that using a left Riemann sum, which means a left rectangular approximation. So in order to do that, we're going to use the interval from 0 to 1, from 1 to 3, 3 to 6, and 6 to 8. So 1 unit, 2 units, 3 units, and 2 units of length there. Everybody good with that? First rectangle will have a height of 1340. Its width is 1. Second one has a height of 1190. Its width is 2. Third one has a height of 950. It has a width of 3. And the last one has a height of 740. And it has a width of 2. Good or no? All right. Add all that together and you get something. I don't know, what do you get? 1, 2, 3. It's like 8,050 if you add those all up, I think. And then it says, is that an overestimate or an underestimate? Well, the only way you can tell if a left Riemann sum is an under or an overestimate is if the function itself is increasing or decreasing, and it specifically says somewhere in here. There we go. R is differentiable and decreasing. So if the function is decreasing, a left Riemann sum will over approximate. So this is an overestimate, and it will be because R is decreasing on the entire interval. Good or no? One point for this setup, 1 point for the value, and 1 point for overestimate because the function is decreasing. All right. Part C. Part C says we want to use our answer from part B to find an estimate of the total amount of water in the tank. So when we think about that, the part C, the total amount of water should be, we'll call this W. W should equal the initial amount. What's our initial amount? I think it's 50,000. All right, 50,000, yeah. And then it should be plus. Did we already have a W? We already had a W of T function, didn't we? Let's not call that W. Let's call this A, amount of water. It's 50,000. And then plus, it should be an integral of the amount pumped in. So this is the rate pumped in. So it should be the integral of this from 0 to 8. And then it should be minus that amount that is removed, 8,050. And you have a calculator, and your calculator will tell you that that comes out to be, to the nearest liter, 49,786 liters. And you got 1 point for using the integral here, and 1 point for the actual answer. Good or no? Everybody good?
Yeah.
Okay. Part D. We want to know if there is a time at which the rate of which the water being pumped into the tank is the same as the rate at which the water is being removed from the tank. Well, what we need to use for this is the intermediate value theorem. So if the water being removed from the tank is the same as the water, if the rate at which it's being removed is the same as the rate at which it's being put in, that would tell you that W of T equals R of T somewhere between 0 and 8. Is that right? It was 8, right? Yeah, 0 and 8. So effectively then what we need to do is we need to see if W of T minus R of T ever equals 0 on that interval. And because we know that both W is a differentiable function, it's a continuous function, and R is a continuous function, it's differentiable and it's decreasing. So they're both continuous functions. So they're both continuous functions. If W of T minus R of T changes signs on 0 to 8, changes signs on 0 to 8, that means that it must have, because it's a continuous function, it must have gone through a place where it equaled 0. And so if we look for the value at the beginning, W of 0 minus R of 0, that comes out to be a positive number. So if you plug in 0 into this, you end up with 2,000 minus 1340. That's positive. But if you plug in 8 and do 2,000 e to the negative 64/20 and subtract 700 from it, that comes out to be negative. And so therefore, because of the sign change, we can say that W minus R must equal 0 somewhere on 0 to 8. And if W minus R equals 0, then W equals R. And your justification would be the intermediate value theorem for that. And then you get 2 points, 1 for looking at W of t minus R of t equals 0. 1 for all the work that shows why it must have changed signs, with an explanation that the intermediate value theorem says that it must have gone through the x-axis or the t-axis. Good or no?
Good.
All right.
Did you have to use IVT, or could you reason your way through it as well?
It depends. I mean, on this one, it didn't specifically say you needed to use the words IVT, but sometimes they do specifically say if you didn't mention intermediate value theorem, or if you didn't mention mean value theorem or whatever, they won't give you the points. So it's good to use the theorem if possible. I don't know. I mean, it depends on what you say. What'd you say on it?
I said they're both continuous, but WT starts higher but ends lower than the rate. So then they must have crossed at some point.
WT starts. Yeah, yeah, that's probably fine. Since it didn't specifically say use intermediate value theorem, that probably would work.
Yeah, thank you.
Mm-hmm. All right. We got rainwater flowing into a drain pipe. We got the pipe being partially blocked. Water drains out the other end. Got a rate at which it drains out. We want to know how many cubic feet of rainwater flow into the pipe during that first 8-hour time interval. So the amount that flows in is just the integral of the rate at which it flows in. Integral 0 to 8. R of t dt is about 76.570. A nice, easy 2 points there. 1 point for the integral, 1 point for the answer. Everybody good with part A? You see that type in almost every single question, and should be easy points. All right. Is the amount of water in the pipe increasing or decreasing at t equals 3? Well, the amount of water in the pipe, to determine if it's increasing or decreasing, we should look at the rates at which it either increases or decreases. And so the rate at which the amount of water is increasing is R of t, and the rate at which the amount of water is decreasing, as it's draining out, is d of t. So we just want to know if R at 3 is greater than or less than d at 3. And so if we do R of 3 minus d of 3, we end up getting negative 0.313632, which is less than 0. And since it's less than 0, that tells us that the amount of water is decreasing. We could say something like the overall rate is less than 0, or that the rate at which it enters is less than the rate at which it drains, or this is the derivative of the function that represents how much there is, and so therefore the derivative is negative, so it's decreasing. Any of those would have worked as an explanation. 1 point for this, 1 point for decreasing with an explanation. Everybody good with part B? All right, part C. We want to know at what time between 0 and 8 is the amount of water in the pipe at a minimum. So we need to write a function to represent the amount of water in the pipe. So we'll just call that A. The amount of water is the initial amount, which was 30, plus an integral from 0 to some t value of the rate at which it enters, which is r of x, minus the integral from 0 to t of the rate at which it drains out, t of x dx. And so to find out when this function is at a minimum, we take its derivative, which is just r of t minus d of t, and set that equal to 0 to see when it's at a minimum. The calculator will tell you that that occurs at t equals 0 and t equals 3.27165. And because this is a closed interval, we will also check the other endpoint. And I wish I just saw your question. Let me just finish writing this out, and then I'll answer your question. So we make the function r of x, because, okay, so we're integrating from 0 to t of this function r of something. It doesn't matter what this variable is, because when we integrate, we're going to put it in terms of t, which is what the variable that we want to use, because that's the variable we're using within the problem. So because it's a definite integral, you just make this variable anything. I can make this r of y dy or r of theta d theta. It doesn't really matter, just so that it's not the same variable as what's up here, because that becomes confusing, because then this is a variable and then that would be treated like a variable rather than a constant. But we need to have t values to plug into the r function when we integrate. So I need to put a t up the upper limit and then any other variable. We call it a dummy variable because it's insignificant what this variable is. It could be any variable just pulled from outside the problem. It could be r of, apples, r of apples, d apples integrated from 0 to t. It doesn't matter. Whatever you want it to be. Okay, so we've got our endpoints and our critical values here. And then we'll just evaluate a at each of those. So a at 0 is 30 plus 0 minus 0. So that's just 30. And then you use your calculator to evaluate the integral from 0 to 3.27, whatever it was, of r minus d. And that one would give you 27.9645561. And when you did it in 8, you'd get 48.5 something or another. And you'd see that the minimum occurred at 3.272 minutes. Were they minutes? Were they hours? I don't know what they were. Hours. So 3.272 hours is when the minimum occurs. And this is a good enough explanation for that. Just having the chart there. And that was worth 3 points. So 1 for setting r minus d equal to 0, 1 for getting your answer, and 1 for the justification. Good or no? All right. Part D says the pipe can hold 50 cubic feet of water before overflowing. After t equals 8, the water continues to flow in and out at the same rates until it overflows. We want to figure out basically when it overflows. We want to find a time w when it overflows. Well, we know how much water is in the tank, right? The amount of water in the tank is 30 plus the integral from 0 to, well, we want to know when it overflows, so we'll call it w when it overflows of r of, whatever you want in here, t or x or whatever, r of t minus d of t. This is how much water is in it at time w when it overflows. We want the amount of water in it to be 50. So we just write that integral and we're good. 1 point for the integral, 1 point for the whole equation. Any questions on part D there? Everybody good with that? All right, and gravel. So we've got gravel arriving, gravel being processed and leaving from a gravel processing plant. It arrives at this rate. It is processed at 100 tons per hour. We want to find G prime of 5. So first off, finding G prime of 5 ought to be pretty easy. You got G of t, just plug in the derivative of this at 5 into your calculator. So G prime of 5 is equal to negative 24.588. And it says using correct units, interpret our answer in the context of the problem. So the correct units are tons per hour because it's the derivative of tons per hour with respect to time. So tons per hour. And we'll say that it means that at t equals 5, the rate at which the gravel is processed decreases at 24.588 tons per hour or tons per hour squared. And this was 1 point for the number, 1 point for the explanation with the correct units. Good or no?
Just a small question. Would the derivative of GT be the rate gravel is processed or the rate gravel is arriving? Because G of t is the rate gravel is arriving.
That's the rate it's arriving, not that. Sorry. I just wasn't reading the question. The rate at which gravel is arriving decreases that. Thank you. See, my reading comprehension skills are decreasing at a rate of, I don't even know what, but they're decreasing at some rate. Make sure your reading comprehension skills don't do that. All right, part B, find the total amount of unprocessed gravel that arrives during the hours of operation on this workday. So the hours of operation are 0 to 8. So part B should just be an integral from 0 to 8 of the gravel that arrives, or the rate at which it's arriving, G of t, which ends up being 825.551 tons. And that was a 2-point problem, 1 and 1. Good or no? Hopefully good. All right, part C, is the amount of unprocessed gravel at the plant increasing or decreasing at t equals 5? Well, the amount of unprocessed gravel would mean we need to compare the rate at which it's arriving to the rate at which it's being processed. So if the rate at which it's arriving is greater than the rate it's being processed, then it's increasing. If the rate at which it's the rate at which it's arriving is less than the rate at which it's being processed, then it should be decreasing. So all we need to do is find the rate at which gravel is being processed at 5, G of 5, which is about 98.140764. You can find that just by plugging in 5 to that and evaluating. We know that that's less than the 100, which is the rate processed. And so if the rate that it's arriving is less than the rate it's being processed, then the amount should be decreasing. And you would have gotten 1 point for comparing these together and 1 point for saying it's decreasing. Good or no? Okay. Part D. So part D says, what's the maximum amount of unprocessed gravel? So we need to write an equation to represent the amount of unprocessed gravel. So the amount of unprocessed gravel, we'll just call that A, because that's what we've been doing all day today, is the amount that we started with, which is 500 tons, plus the integral from 0 to t of the rate of change of the gravel, which would be the gravel arriving minus gravel being processed. And so to find when that function is at a maximum, take its derivative. A prime ought to be g of t minus 100. And we want to know when is the derivative equal to 0. So when is g of t equal to 100? Well, that happens when t is 4.923480. And then just like the last problem, we'll make a chart of t values and a values using our endpoints and our critical values. And at 0, it should be 500. And at 4.923, when you plug in that to this integral for the t value, you get 635.376123. And when you plug in 8 to that, you get 525.551089. And we would see that the maximum occurs at 4.923 hours, and that maximum is 635.376123 tons of gravel. And that part was 3 points, 1 for setting this thing equal to 0, 1 for the correct answer, and 1 for the chart to justify. Good. Any questions on that one? Everyone's good there. Yes, I can show the answer to C. Answer to C is right there. All right. So give me 1 second here. And I will grab the book with the multiple choice. So we can get back to that. So I don't remember the last one we did, but I do have the entire list of the ones everyone wanted. So let's see. I think we were doing stuff in the 40s. I think the last one we did, I don't know. Did we do 40? We did 43, I think. Did we do 44? And 45? We finished after 45. Okay. All right. So the next one that was asked for was 46. So 46 says if f of x is continuous on, so we'll say f is continuous on a to b, then there exists at least one number c on the interval from a to b such that the integral from a to b of f of x dx is equal to what? And so for this one, they are just having us look at the mean value theorem for integrals. So this is just, that's the only theorem we really got with our integrals that we'll deal with. And so we know that the average value of a function ought to be that f of c value. And so normally this has a 1 over b minus a in front of it. So we know that just the integral from a to b of f of x dx is equal to, b equal to b minus a times f of c. And so that looks like choice C. That's just the mean value theorem for integrals. Everybody okay with that one? Okay, next one was 24, but I think we already did 24. Yeah, we did that one. The next one was 27, which I think we also already did. Yep. We did that one. Next one was number 2. So number 2, we're looking at an integral from 1 to 2 of 3x minus 1 over 3x dx. So for this one, anytime you've got a rational function with just a single term in the denominator, just divide both of the, or however many of the terms there are in the numerator by that single term. So this becomes an integral from 1 to 2 of 3x over 3x, which is 1, and then minus 1 over 3x dx. And now this is a lot easier to integrate. So we've now got x minus, and this is just 1/3 of 1 over x. So 1/3 natural log absolute value x, and we'll evaluate from 1 to 2. 2 minus 1/3 ln 2 minus 1 minus 1/3 ln 1. ln 1 is 0. This is 2 minus 1, or 1, minus 1/3 ln 2, which looks like it is choice B. Everybody good with that one? All right, so next one was 27 again. So we've already done 27. So we don't need to go back to that. Next one was 29. So 29, a picture and a lot of words here. 29 says we got the function. What is our function? 1 over x, I assume. Yeah, 1 over x. And we're talking about a region between 1 and 2, and a region between 2 and 3. And then it wants us to approximate using a left and a right rectangular approximation using 2 subintervals. So it tells us that this exact area in here, which we should be able to find, is just the natural log of 3. Yellow is kind of annoying. I won't use that anymore. But we know that this yellow is the natural log of 3. If we were to use a left Riemann approximation, does that approximation give us a value that is greater than or less than the natural log of 3?
greater than?
Should be greater than the natural log of 3, right? And the value of that is 1 by 1 unit high, right? Because this is 1 over x. So 1 plus a half times 1. So it tells us that 3/2 is greater than ln3. And if we use a right Riemann approximation, I'll use a different color for this. I want to use a different color for this. There we go. Our right Riemann approximation looks like this, which is clearly less than the actual value of natural log of 3. That's 1/3 plus 1/2, which is 5/6, and that must be less than the natural log of 3. So that tells us that 5/6 is less than ln3, which is less than 3/2. Or, you know, they wrote this, looks like in the answer choices, they wrote this as the integral from 1 to 3 of 1 over x dx. So looks like that's choice E. Any questions there on 29? All right. Next up is 39. 39 gives us a graph of a function, looks like this. This point is the point 2, 10. This point is the point 5, 10. It says find the average value of the function on the interval 0 to 5. So the average value of a function is 1 over b minus a times the integral from a to b of that function. This is f of x. Well, the integral of f of x from 0 to 5 is just the area underneath this curve, which can be broken down into a triangle and a rectangle. Right? 1/2 base times height. So 1/2 of 2 is 1 times 10 is 10. And then this one is 2 to 5 is 3 times 10 is 30. So this tells us that the average value is 1/5 of 40 or 8. Any questions there on 39? All right. 43 we already did. 45 we already did. So next one was 51. So for 51, it says if x equals 4 cosine theta and y equals 3 sine theta, then the integral from 2 to 4 of xy dx is equivalent to 2. And so this is similar to a couple of the ones we were doing earlier, yesterday or Friday or whatever day it was, where you had to rewrite everything into terms of theta. So x is 4 cosine theta, y is 3 sine theta, so that should be 12 sine theta cosine theta. That's xy. Dx, well, dx is negative 4 sine theta d theta. And then our limits of 2 and 4, those are x values because this is dx. So we need to plug 2 equals 4 cosine theta in, or 1/2 equals cosine theta, or theta equals pi over 3. Then we'll plug in 4. 4 equals 4 cosine theta, or cosine theta equals 1. Cosine theta equals 1 when theta is 0. So looks like this should be choice looks like that should be choice C. And the way we get choice C out of that then is this is a negative 48. You can pull the 48 out, right? And I can get rid of the negative if I flip the limits of integration, so make it 0 to pi over 3. And then you got a sine squared theta cosine theta d theta. Good or no? Oh, sorry, that's choice E. I just looked at them in the. I thought it was A, B, C going down there on those choices, but choice E. Any questions there on 51? All right, 54 is the next one we're talking about here. It says the average value of f of x, where f of x is equal to x cubed if x is less than 2, and 4x if x is greater than or equal to 2 on the interval 0 to 5. And we want to find the average value. First thing it says is it's undefined because f isn't differentiable. Well, you can still find the average value of a function if it's not differentiable. It just has to be continuous. So choice E doesn't make any sense. Now, if that said undefined because f is not continuous, you need to check to make sure this is continuous. And in fact, you should probably check anyway. But 2 cubed is 8, and 4 times 2 is 8, so it's continuous at 2. So it's continuous everywhere on 0 to 5 because it's continuous at the breaking point, and it's continuous because it's x cubed and it's 4x, which are always continuous. So then to find the average value, we just need to find the value of 1 over 5 minus 0 times the integral from 0 to 5 of this function. Well, to find the integral from 0 to 5 of this function, we've got to find the integral from 0 to 2 of x cubed and add to that the integral from 2 to 5 of 4x dx. So we've got 1/5 of x to the 4th over 4 from 0 to 2 plus 2x squared from 2 to 5, or 1/5 of 4 minus 0 plus 50 minus, what is that, 8. So we got 4 plus 42 is 46, and we end up with 46/5, which is, I guess, choice B, 9.2. Now, this was a calculator problem, so you could have, this is in the calculator section. You could have the calculator evaluate those integrals for you, but either way, we did it by hand. We're better than the calculator. Any questions there on 54? Our next one is number 18. 18 gives us an integral from 0 to pi over 6 cosine theta over 1 plus 2 sine theta d theta. And so we want to integrate this. Probably our best bet here is going to be doing a u substitution. So let's let u equal 1 plus 2 sine theta, because then du will just be 2 cosine theta d theta. We can put a 2 and a 1/2, and we'll end up with 1/2 the integral of du over u. And we can go back in and we can plug in 0 into this. And 1 plus 2 times the sine of 0 is just 1. And then the sine of pi over 6 is a half. So 2 times a half is 1 plus the other one is 2. We've got 1/2 the integral of du over u from 1 to 2, or 1/2 natural log absolute value u from 1 to 2. or 1/2 natural log 2 minus natural log 1. Natural log of 1, of course, is 0, so this is 1/2 the natural log of 2, which is choice E, because this is a power of 1/2 if you bring it inside the natural log. Right, 2 to the 1/2 power. Natural log root 2. Hey, everybody good there with 18? Y'all doing all right out there? Okay. Next one was 27. We've done 27. Then 28. Okay, 28 says the graph of a continuous function passes through the points 4, 2, 6, 6, and 7, 5. Oh, and 10, 8. Missed that one almost. Using trapezoids, we would estimate the integral from 4 to 10. So we'll do trapezoidal. We'll do a trapezoidal approximation for the integral from 4 to 10 of f of x. So the trapezoidal rule just says if you don't have equal subintervals, you have to find the area of each trapezoid and sum them together. So from 4 to 6, 6 to 7, and 7 to 10, those are not all equal subintervals. So the first trapezoid will be made from 4, 2 to 6, 6. So base 1 should be 2. Base 2 should be 6 divided by 2. Multiply it by the height, 6 minus 4. There's your first trapezoid. Second trapezoid should be 6 plus 5 divided by 2 times, that one has a height of 1 from 6 to 7. Next trapezoid should be 5, or last trapezoid should be 5 plus 8 divided by 2 times a width of 3. So what is this? This is 8 over 2 is 4 times 2 is 8 plus 11 halves. This is 13 halves times 3, which is 39 halves. So we got 50 over 2 is 25 plus 8 is, looks like 33. Looks like that's choice D. Any questions there on 28? All right, next one is 29. We just did 29. All right, next one is 30. We did 30 yesterday, I believe. All right, next one is 31. All right, 31 says the integral from -1 to 3 of the absolute value of x dx. Well, we should know what the absolute value of x dx looks like, since that's the one that we don't have just a straight up integral for. We should just be able to graph it, and the area between -1 and 3. Well, this is the point 3, 3, and this is the point -1, 1. So if we're looking for the integral from -1 to 3, it's just the area of this triangle plus the area of this triangle. So 1/2 base times height for the first one, plus 1/2 base times height for the second one. I don't know why I wrote 9s when they're 3s. Probably because 3 times 3 is 9, so we get 1/2 plus 9 halves, or 5. Choice D. Everybody good with 31? Any questions there on that? Okay. Next question was 32. This is essentially like the same basic question. But integral from -3 to 2 of absolute value of x plus 1 dx. Well, the absolute value of x plus 1 is just the same as absolute value of x, except it's 1 unit to the left. So this is -1. We're going from -3 to 2. So the point at 2 should be 3 units up, and the point at -3 should be 2 units up. So we're just looking at the area of this triangle plus this triangle, 1/2 base times height plus 1/2 base of 3 times height of 3. So 2 plus 9/2, or 13/2. Any questions there on 32? All right. Next one is 36. So 36 says choose the Riemann sum whose limit is the integral from 1 to 5 of x cubed. Well, we know that it's always the limit as n approaches infinity of the sum from k equals 1 to n of f of x sub k times delta x. And as we talked about before, delta x is always equal to b minus a over n, and x sub k is always equal to a plus k delta x. So if you can remember all of that, that's good news. Remember, delta x is just the length of the subinterval, so the length of the entire interval divided by n. And then this is the height, the x value that we go over to plug into our function to find the height of each of the rectangles. So width of the rectangles times height of the rectangles. So we should end up with the limit as n approaches infinity of the sum from k equals 1 to n of f of x sub k. So that'd be x sub k is 1 plus k times delta x, and delta x is b minus a over n, which is 4 over n. So this should be k times 4 over n. So we should end up with 1 plus 4k over n, or x sub k, cubed times delta x of 4 over n. And looks like that is choice B. No, not choice B. Choice C. 1 plus 4k over n cubed times 4 over n. Good or no? Next one is 49. All right, number 49. Sorry about that. So we are given a function capital F of u, which is the integral from 1 to u of 2 minus x squared cubed dx. We want to find f prime of u. Well, f prime of u is the derivative of the integral from a constant to u of some function. So f prime of u should just be a simple substitution of the u into this, 2 minus u squared cubed, and that should be literally it. That's just the fundamental theorem of calculus. So it looks like that's choice D, 2 minus u squared cubed. If this was something else, like if this was a u squared, then we'd have to plug in a u squared here and multiply it by the derivative of u squared. Everybody okay there at 49? All right, next one is 51. We did 51 already. Next one after that is 25. Okay. So 25 is, we're going to use the substitution u equals root x plus 1. And we're looking at the integral from 0 to 3 of dx over x root x plus 1, with u equal to root x plus 1. So they want us to rewrite that however we can. So probably the best way to go about this one would be for us to, give me 1 second here, sorry. Somebody's trying to enter the room and then I messed up. Now I'm letting them in. Okay, so the best way for us to take a look at this one is to first off recognize that this root x plus 1 is going to become a u. And so this will become an integral from 0 to 3 of dx over x times u. But then we also have to replace the x. And so to do that, we can solve this for x. So u squared equals x plus 1, or x equals u squared minus 1. So this now becomes the integral from 0 to 3 of dx over u times u squared minus 1. But now we got to turn it all into terms of u. So that means we got to replace the dx. Well, dx will be 2u du. So now this can become 2u du over u times u squared minus 1. And since we changed the limits of integration, so since we changed everything inside of here to terms of u, we had to change our limits of integration to terms of u. And u is root x plus 1. So if x was 0, root x plus 1 is root 0 plus 1, or 1. And if x was 3, u is root 3 plus 1, which should be 2. And then we can simplify the u's. So integral 1 to 2 of 2 du over u squared minus 1. Looks like, I don't know, what choice is that? 2 du over u squared minus 1 from 1 to 2. Looks like that's choice B. Everybody good there with that one? That is the last one that was asked for that we haven't already done. The next one was in 36, but we already did it. Anybody have any other questions on any of that multiple choice stuff? Any other questions? I feel like I did almost every single one.